Hello CHEM203 students. Today we will perform the last experiments of our course entitled Total Hardness of Water, in which we will perform a complexometric titration. In the first part of the experiment, we will prepare a solution of 0.01 molar EDTA. We will start by weighing 2 grams of EDTA using a weighing boat. We will weigh 2 grams of EDTA Here's 2 grams of EDTA. We add to the weighing boat directly 3 crystals of MgCl2 hexahydrate . And now we need to transfer EDTA with MgCl2 to a 500 milliliter volumetric flask. Using distilled water, we make sure that there is no residue of our powder on the weighing boat. And now we add more distilled water to the volumetric flask . And we will dissolve the solid before continuing till the mark and homogenizing. So by swirling our volumetric flask, we are trying to dissolve all the powder . We can add a little bit more water . We continue dissolving . A little bit more until all the solid is dissolved. Now all EDTA is dissolved, so we continue the volume with distilled water till the mark . Don't forget to use a dropper before you reach the meniscus. And here is our EDTA solution ready. So we homogenize and we label our volumetric flask with EDTA solution. Part 2 of the experiment, we will prepare a standard calcium solution. We will start by weighing 0.4 gram of calcium carbonate We're done. We don't forget to close the bottles after each usage. And now we must transfer the 0.4 gram of calcium carbonate to a 500 milliliter volumetric flask. Using distilled water, we make sure that there is no more powder on the weighing boat. We add around 100 milliliter of distilled water, and now before continuing with distilled water till the mark, you can notice the effervescence in our volumetric flask. So we have to remove it using a solution of 6 smaller HCl. So using a dropper, you will add drop-wise HCl to the calcium solution. You keep adding until no more effervescence and your solution is clear. You can see how the solution is getting clear. You can see how effervescence ceases, and we have a transparent solution. So you stop adding HCl, and now we continue with distilled water up to the mark. As previously mentioned, you need to use a dropper as soon as you approach the mark. And here we are ready with our standard calcium solution. We homogenize and we label calcium solution. Moving to the third part of the experiment, we will standardize EDTA the prepared EDTA solution with the standard calcium solution. Why do we standardize EDTA? Because it's highly consumed with water while preparation. So first we have to clean our burette with a small volume of distilled water. Then, with a small volume of EDTA solution, and now we will fill the burette with EDTA. Okay. You can see the bubbles in the burette, so we have to remove them by opening the stopper. No more bubbles. And we will add more EDTA in order the meniscus is tangent to 0. The burette is ready. Now we have to pipette. We will repeat the titration twice. So we have to pipette 50 ml of the calcium solution, the prepared standard calcium solution, in each Erlenmeyer. Okay, 50 ml pipetted in the first Erlenmeyer. Another 50 ml will be pipetted in the second one. Okay. To each Erlenmeyer we will add buffer solution, ammonium chloride buffer solution, because we do need a basic media during the titration. So to each one, using a graduated cylinder, 5 milliliter, you can add the buffer solution to each Erlenmeyer. And we add to each Erlenmeyer our indicator Aerochrom black tea. 5 droppers, 5 to each Erlenmeyer, and we are ready for titration. You can see that we have a brick red color. So the color while titration, in order to reach the equivalence point, must shift from brick red color to blue color. We add our magnetic bar and we start our titration. Since we do not have any idea about the volume, so we must add drop by drop until we see a color change to blue. No color change is seen. We should wait more. Around 10 milliliter EDTA are added so far, and there is no color change. The color is still brick red. The volume of 38.2, and there is a color change from red wine to blue. So we record on the report the volume of equivalence 1, which is 38.2 milliliters. Now we will fill again the burette with EDTA in order to perform the second titration. We remove the funnel and we adjust the meniscus at 0. Here we are. We add the magnetic bar. We turn on the stirrer. And now, as we have an idea about the volume, since in the first titration we got a 38.2 milliliter volume of EDTA at equivalence, so we could add up to 35 rapidly, and then we will proceed drop by drop. Okay, after we reach 35 ml, we start adding drop by drop slowly in order for the color to change. I think we need, we have reached the blue color, so at a volume of also 38.2. 38.2 milliliter. So for the standardization of EDTA, the two volumes are the same, are obtained the same. In the last part of the experiment, we will be determining the total hardness of a given water sample. We will repeat the titration twice, so I will prepare in 2 Erlenmeyers. In each one, we have to pipette 25 ml of the given water sample. Also in the second Erlenmeyer, we will pipette 25 milliliter of water. We will add to each Erlenmeyer 1 milliliter here of the buffer solution. And we will add 5 droppers of Aerochrome black tea indicator. 4, 5. 1, 2, 3, 4, 5. So 5 drops of the indicator are added. And we can start our titration. We have the titrant still our standardized EDTA solution. We should not forget to add the magnetic bar. And now we will add dropwise in order also to reach the blue color. We have a red brick red color, and it must shift to the blue color at equivalence point. So we don't know at which volume the color will shift, so we have to go dropwise, and we have to be careful for the color. And the blue color is reached at a volume of 3 milliliters. We will record on the report. The first volume is 3 milliliters. Now we have to do the second titration. We refill our burette with EDTA solution. We turn on the stirrer, and also we add dropwise we will wait for the color to shift to blue. You can see how the color has changed to blue at a volume also of 3 milliliters. These are the results. You will use the volumes in your calculations. And we're done.